This is part 2 of the Chapter 13 lecture video series. So let's talk about some of the advantages of using a repeated measures design. So a lot of these advantages are going to be in relation to either the t-test that we talked about in Chapter 11 or the between subjects ANOVA that we talked about in Chapter 12. So one of the advantages that this type of analysis has over specifically the t-test that we did in Chapter 11 is the ANOVA allows us to examine more than two groups or conditions or time points versus the t-test that we talked about in Chapter 11, the related samples t-test. It was only limited, or it was limited to only two time points or conditions. So the major advantage that ANOVA in general offers beyond what a t-test can do is that it allows you to look at more than two levels or conditions. And specifically in this chapter, remember that we're looking at how people are changing across these different conditions. So how the same group of people change across the various levels that we're measuring. Another advantage of this type of research design is that, as I've mentioned in the previous video, we can identify and eliminate the extent to which individual differences are affecting our outcomes. And the way we do this is we look specifically, kind of similar to what we did in the related samples t-test. We're specifically focusing on how each individual person changes from one condition to the next. So let's say that our treatment, we're trying to make people happier by giving them this happiness pill. So we can look to see how they change in happiness from the actual happiness pill to the placebo, right? And it doesn't necessarily matter where they started. So they could have been really high already on happiness or really low on happiness. It doesn't really matter where they started from. What matters more is how they changed from one condition to the next. So that's how it eliminates those individual differences, those starting points where we don't know why people started out more or less happy. What we really care about is how they changed from one condition to the next. And finally, another advantage of this type of research design is that just in general within subjects research designs, where we have the same person in each of our different conditions, so one group of people that gets all of our different conditions, it always requires fewer participants. So remember that with a between subjects design, when we have completely different people in each group that we're comparing, we have to have at least 30 people in each of those groups that we want to compare. So that is not so much the case for repeated measures design because you have the same people in each of your different conditions that you're comparing. So even if you were comparing 3 different time points, if it's the same people measured at each of those different time points, you still only need 30 people because those same people are going to be measured at each of your different time points. Whereas if it was a between subjects design, you would need, since it's different people in each of the groups you're comparing, you would need 30 people in each of your 3 groups, which is a total of 90 participants. So this type of research design really allows us to have fewer participants overall in our whole study. So of course there's also some disadvantages associated with this type of research design, and one of the main disadvantages would be the order effects that could potentially affect the DV. So if we are thinking about this happiness drug versus a placebo, it is possible that, if we give them the happiness drug first and then measure their happiness, and then we give them the placebo next and then measure their happiness, it's possible that the effects of the drug could carry over into that second time point. And so that's a potential order effect issue where the order of your treatments might have a different effect on your dependent variable. So maybe the effects of the happiness pill carry over into the placebo condition, but not vice versa. So maybe the placebo effects wouldn't carry over into the actual treatment condition. So it's hard to know that if you actually are, measuring the effects that are just due to that one condition that the participants are in at that given time point, or if there was some kind of carryover effect from the previous condition. In addition, we also have testing effects that are a problem in this type of research design, and there are specific testing effects that we tend to see, which is if you're doing a skill-based task, people tend to get better at that task over time. So if you're giving them math problems repeatedly over several different time points, they should get better at those math problems over time. Conversely, people could also get bored doing the same sort of study over and over again. So for other measures that might not be skill-based, people might just get bored and lose motivation to actually thoroughly participate in the study if they are bored. So that's another potential testing effect, that people might care less about your study if you keep asking them the same questions over and over again. Usually that often leads to dropout as well. So one of the really difficult things about a repeated measures design or within subjects design is it often requires you to have the same people show up somewhere more than once. Once you start doing your own research, you'll realize how difficult it is to just get somebody to participate once in a study. This becomes exponentially more difficult when you have to have people show up once and then show up again at another time point. So often what the case is maybe they'll show up once and then kind of forget about your study or drop out for whatever reason. Once a person drops out of your study, if it's a repeated measures design or within subjects research design, that person can no longer be considered a participant in your study because you only have their measurement at one of the conditions. So you can't look to see how that person changed across the conditions if they actually weren't measured at all of your conditions. So dropout is a huge issue with a repeated measures design. So it might sound easier in some ways because you need fewer participants. However, the issues of dropout greatly reduce your ability to collect data from people over repeated measurements. So those are some of the advantages and disadvantages of this type of research design. Remember that essentially the between subjects research design, it has the opposite advantages and disadvantages of the within subjects research design. So many of the disadvantages here are advantages for the between subjects research design because they aren't issues in that type of research design. So let's talk about an actual hypothesis test example for this type of ANOVA. So with this type of ANOVA, here's an example research question. So let's say a researcher wants to examine the efficacy of a GRE prep class. So GRE is just like the SAT, except for graduate school. So they want to see if this class that's meant to prepare students to take this exam, they want to see whether or not it's effective. So to examine whether or not this prep class is effective, the researcher has students complete the practice GRE before starting the class. So that would be their baseline measurement. And then after getting halfway through the class, she again has them complete a practice GRE. So this would be the GRE measurement at the midpoint of the class. And then also the researcher has the students take the practice GRE again at the end of the class. And so we want to know if this prep class actually led to any changes in GRE scores. So it gives you an alpha level to use to test this hypothesis. So some things I wanted to point out in terms of this question. Our first, we have, our three different conditions or three different time points that we're comparing to each other. So those three different time points that are being compared are the baseline, the midpoint, and the end GRE scores. So we know that this is a repeated measures ANOVA, or also known as a within subjects ANOVA, because we have the same people that are being measured at each of those three time points. So since there are three levels here, three different time points, we couldn't do a t-test because, again, the t-test would be limited to just comparing two different time points. So since we're comparing the same people at three different time points on a dependent variable that's measured with numbers, so the GRE is measured with numbers, we're going to use a repeated measures or within subjects ANOVA to answer this research question. So let's talk about how we're going to write our hypotheses related to this type of ANOVA. So in step one of our hypothesis testing procedure, we're always going to state our competing hypotheses. So our two competing hypotheses in this type of ANOVA, the first one would be that there is no difference in the GRE scores across these three different measurements. So remember that we're always hypothesizing about the population level mean. So that's why you see the symbol mu there. The symbol mu, again, represents the population level mean. So if we were to hypothetically give the GRE to every single person in the population, let's say all students who are going to take the GRE, their mean at the baseline would be equal to their mean after getting halfway through this prep class. So again, we're hypothesizing about the population level. So if hypothetically we were to give every single student this prep class, and midway through the prep class we were to measure their GRE score, it would be equal to what it was at the baseline. And then also it would be equal to what their average GRE score would be after taking the class. So essentially what this null hypothesis is, the H subscript O, is saying that these students' GRE scores are going to be the same across each of these measurements. So there's no difference or no change in their GRE scores depending on when it was measured. It's all the same GRE score. And our alternative hypothesis, that H subscript 1, is going to state that at least one of our mu's is different. So recall from the last chapter that ANOVA has a lot of different possibilities that are not the null hypothesis. So it's possible that maybe the baseline is different from the other two, maybe the midpoint's different from the other two, or maybe just the end is different from the other two. Or also, it's possible that all three are different from each other. So there are a lot of different possibilities of differences that we could find in this analysis. So that's why we always state our alternative hypothesis by just saying that at least one of those time points is different, and then we'll continue on later to explain which ones are different. So those are our two hypotheses that we're going to be testing out in this ANOVA.